When Martin begins his senior year of high school, he predicts the value of his college savings in an annuity that earns 6% annual interest compounded monthly. Martin uses the function v of x equals 23,250 times 1 and 5 thousandths to the x, where 6% divided by 12 months is 5 thousandths. X represents the number of months since his senior year in high school began, and v of x represents the value of his college savings to create a table. Martin will need $24,060 to pay for his first year of college. How many months into his senior year of high school will his savings completely pay for his first year of college? Write an equation related to v of x that will answer the question and use the table to approximate the solution. Okay, so we want to know when Martin will have $24,060 in his account. And we have this equation that tells us how much he makes for every month, which is our x value there. And so then v of x is the amount it tells us that is in his college savings. And so we want to know then, well, when will v of x equal that $24,060? So we can just go ahead and substitute in 24,060 for v of x in our equation. And so now that we have that, then we can look at our table and see, well, does v of x ever equal $24,060? And if so, then what's the x value there? And so looking at our v of x, which is the right column here, then we're looking for 24,060. Okay, so it hits 24,076. That's really close. And then, so it's definitely going to be right before 7 months, which is the x value there. But 6 months is still too small. And so we know that it'll be somewhere in between 6 and 7. And let's just talk about what it means to be compounded monthly. So if something is compounded continuously, then you could basically take out your money on any day and it's still being compounded all the time. So you're going to get that percentage. But if something's compounded monthly, then you don't actually receive the interest until that month. And so basically, even though at 7 months it's actually a little bit bigger than $24,060, because it's only compounded monthly, he's only going to get higher than 24,060 at 7 months. So basically, he needs to wait till 7 months to be able to get that full amount. And if you did want to find the exact amount, then you could, as we've done before, you can find the intersection of where our function here on the right intersects 24,060 in a calculator. So you could put these into y1 and y2 and find the intersection. And if you do that, it actually does end up to be 6 and 866 thousandths months, right? And so if this was compounded continuously, then you would say, well, yeah, right, at 6 and 866 thousandths of a month, then he's going to have that many. But since it's compounded monthly, then we know our answer will just be 7. And so let's go ahead and summarize our answer. The equation in a solution answers the question, is 24,060 equals 23,250 times 1 and 5 thousandths to the x. The model v of x equals 23,250 times 1 and 5 thousandths to the x predicts that there will be $24,060 in Martin's college savings after 6 and 866 thousandths months. However, the interest earnings on the account are only calculated once per month instead of continuously during the month. Therefore, it will take 7 months into his senior year for the balance of Martin's college savings to completely pay for his first year of college.